Here we are asked to find the cosine value of 2 theta and the sine value of 2 theta when you're given information about theta. Cosine theta is equal to negative 12 over 13. Keep in mind that all of this information is not about 2 theta. Here we are told information just about the angle theta. Theta has a cosine value of negative 12 over 13, and we are told that sine of the angle theta is greater than 0. If sine is greater than 0, that means sine is positive, and we are told that cosine is negative. So if sine is positive and cosine is negative, then theta must be in quadrant 2. So we want to know, what is cosine of 2 theta? We know what cosine of theta is, but what is cosine of twice that angle? Well, we need to use one of our double angle identities. We can use any of the cosine double angle identities. We have 3 of them to choose from. You can choose any of the 3. All 3 of them will work. I'm going to choose cosine squared theta minus sine squared theta. If I know what cosine is and what sine of theta is, then I can plug them into this formula and then solve for cosine of 2 theta. So we need to know what cosine theta is, square it, subtract from that sine theta, and square it. We are told that cosine of theta is negative 12 over 13. So we're going to put that into the formula. What we don't know is what is sine of theta. So if cosine is negative 12 over 13, then we actually know x is a negative 12 by definition of cosine, and r is a positive 13. The only thing that we don't know is what is y. So we're going to use the Pythagorean theorem. X squared plus y squared equals r squared, and we will square x. Negative 12 squared is 144 plus y squared. 13 squared is 169. Subtract 144 from both sides. We get that y equals 25. And then we take the square root of both sides. We get that y is either plus or minus 5. Is y plus or minus? Well, we go back to the information that we are given. We are told that sine is positive, and we determined that we were in quadrant 2, so the y value must be positive. So y is positive 5. Remember that all of this information here is about theta, not about 2 theta. Sine of theta is y over r, so that's 5, the y value that we just found, divided by the r value of theta, which is 13. Now we need to simplify. So we will square each fraction. 144 divided by 169 minus 25 divided by 169. Keep the same denominator. Subtract the numerators on top. So we get 119 divided by 169. Cosine of theta was a negative value, but cosine of 2 theta is a positive value. We will talk about y in just 1 minute. Now we want to solve for sine of 2 theta. So sine of 2 theta, we will use another one of our identities. Sine of 2 theta is equal to 2 sine theta times cosine theta. We actually know sine and cosine theta, so all we have to do is plug that information into the formula. Sine theta is 5 divided by 13. Cosine theta was negative 12 divided by 13. Let's multiply all 3 of these values. We'll think about this as 2 over 1. We have 2 times 5, which is 10, times negative 12. So that gives negative 120 divided by 1 times 13, which is 169. So sine of 2 theta is negative 120 divided by 169. We were originally told that sine theta was positive, so why is sine 2 theta okay to be negative? We used the information that we were given to determine that theta was in quadrant 2. If theta is in quadrant 2, so here's quadrant 2, the angles in quadrant 2 range from 90 degrees to 180 degrees. So we know that if theta lives in quadrant 2, that theta is between 90 degrees and 180 degrees. So it lives somewhere within those values. What about 2 theta? Now remember, this is a double angle, so that means twice the angle theta. If I wanted to double this angle, I could double each part of this inequality. So if I multiply everything through by 2, then we can determine that 2 theta would live between 180 degrees and 360 degrees. So if I double an angle that lives in quadrant 2, I could potentially get an angle that lives somewhere here in either quadrant 3 or in quadrant 4. Where does 2 theta live? Well, we can tell that sine was negative, cosine was positive, so that must mean that for this particular problem, 2 theta lives in quadrant 4, where cosine is positive and sine is negative. Here we are given some information about the angle x, and we are asked to determine, given this information about the angle x, to find cosine of 2x and sine of 2x. So we want to find out information about the double angle given just the angle x. Tangent of x is equal to 5 divided by 3, sine of x is less than 0. If tangent is positive 5 over 3 and sine is less than 0, then sine is negative. So our angle x must be in quadrant 3. What information are we given and what do we need to find? We want to find cosine of 2x. So once again, we will use a double angle identity. And I'm going to choose one of the 3. It doesn't matter which of the 3. I'm going to use cosine squared x minus sine squared x, which means I need to know what cosine is, the cosine value of x so that I can square it, and I need to know the sine value of x so that I can square it. Once I know those values, then I can plug the information in and then find cosine of 2x. Since we are told the tangent value, we know that we have y divided by x as the definition of tangent. So x is equal to 3, y is equal to 5, and r is the value that we want to solve for. Once again, we will use the Pythagorean theorem. Since we are in quadrant 3, the x value is negative and the y value is also negative. So negative 3 squared will give positive 9. Negative 5 squared would be a positive 25. 9 plus 25 is 34. We want to take the square root of both sides. We don't need to put the plus and minus because we remember that r is always positive. So the r value is the square root of 34. Now that we know x, y, and r values for our angle x, let's plug the information into our formula. For cosine, we know that cosine is x divided by r. So that's negative 3 divided by the square root of 34. Sine is y divided by r, so that's negative 5 divided by the square root of 34. And now we want to simplify. Anytime that we square a value that is negative, we get a value that is positive. So negative 3 squared would be positive 9. Square root of 34 squared, we just get 34. Minus, squaring just what's in the parentheses here, we get a positive 25 divided by 34. 9 minus 25, we get a negative 16 divided by 34. And we need to reduce this fraction. Dividing by 2 on top and the bottom, we get negative 8 over 17. And that is our cosine value of the double angle, cosine value of 2x. How do we find sine of 2x? We're going to once again use our double angle identity. Cosine of 2x is 2 times sine x times cosine x. And we already know the sine value, that was minus 5 divided by the square root of 34. And we already know the cosine value was minus 3 divided by the square root of 34. We need to multiply these three values together, so we'll think about this as 2 over 1 and multiply across. 2 times negative 5 is negative 10 times negative 3, that gives positive 30. Multiplying across the bottom, we have 1 times the square root of 34 times the square root of 34, which is just 34. And then once again, we want to reduce. So we get a positive 15 divided by 17.